Now let's talk about the angle bisector theorem and its converse. Before we do, I'm going to introduce you to a definition. What we call the distance from a point to a line is the length of the perpendicular segment from the point to the line. So therefore, the distance from K to M is the length of the segment MK, or also known as MK. And the distance from H to the line N is the distance of the segment HW, also known as HW. I also want to show you something else that you might find interesting. If we look at the length of HW, we can see that it is 1 3/10 centimeters. So what we do is we measure the length of that perpendicular segment. But wait, that's not all. Notice that the length of segment MK is about 3 3/10 centimeters right here. But notice, if it's not on the perpendicular, it's actually longer, 3 4/10 centimeters right there. We just moved the ruler just a few degrees off, and we've increased the length of the segment. So the reason why we want to use the perpendicular length is because it is the shortest length from the point to the line. Because we want to talk about the angle bisector theorem, I'm going to start by constructing an angle bisector to angle V here. So we're going to make an arc with our compass at V, and we're going to label the points where the arc intersects the angle, points A and B. And then I am going to take my compass point and put it on A and make an arc. From there, I will move my compass point to B and make an arc. And now where these arcs intersect, and using the vertex, we can draw in our angle bisector. And I'm just going to put a point somewhere on that angle bisector. We'll call that point P. So now ray VP is the bisector to angle AVB. Now, the reason why I introduced the definition of distance from a point to a line is I am now going to look at the distance from point P to the rays of the angle. So in order to do that, I need the perpendicular segments. And so there we go. Segment PG is perpendicular to ray VG, and segment PU is perpendicular to the ray VU. So that would mean that PG is the distance from P to the ray, and PU would be the distance from P to the other ray. Now we already know that these two angles, angle GVP and angle UVP, are congruent because we constructed the angle bisector. We also know that segment PV is congruent to itself by the reflexive property of congruent. And we also happen to know that angle PUV and angle PGV are right angles, which makes them congruent by the right angle congruency theorem. So by angle, angle, side, we have two congruent triangles. Triangle PGV is congruent to triangle PUV. And because the triangles are congruent, their corresponding parts are congruent. So notice that we have just proven that a point on the angle bisector is the same distance away from both rays. And yes, that is our angle bisector theorem. If a point is on the bisector of an angle, it is equidistant from the sides of the angle. So with that, let's now talk about the converse of the angle bisector theorem, which, you guessed it, reads, if a point is equidistant from the sides of an angle, then it is on the angle bisector of the angle. Let's take a few moments and work out an example involving this. Using the angle bisector theorem. In this problem, you will notice that ray TH bisects angle NTR. Because it bisects the angle, we know that any point on the angle bisector is equidistant from the rays. So therefore, we know the distance from H to N is going to be the same or equal to the distance from H to R. And so now we can plug in the values. The distance from H to N is 5x, and the distance from H to R is 8x minus 24. Using the subtraction property of equality, we can subtract 8x from both sides of the equation, leaving us with the opposite of 3x is equal to negative 24. And then finally, we can use the division property of equality and divide both sides of the equation by negative 3, telling us that x is equal to 8. But wait, we're not done, because we were asked to find the length of segment HR. So now what we're going to do is take that 8 and plug it into our expression for HR. So we have 8 times x, which was also 8, minus 24. 8 times 8 is 64. 64 minus 24 is 40. So there's a quick application of the angle bisector theorem. And now it's your turn to try a couple of questions.